Density functional theory is one of the most popular methods of computation in quantum physics. However, before we can begin to discuss it, we must review a few concepts first. 1. Wave-particle duality. Electrons can be described both as a particle,
I'm a particle! Yeah!
and as a wave.
I'm a wave!
2. The Heisenberg uncertainty principle, which states that both the velocity and the position of an electron cannot be known at the same time.
I have no idea where I am or how fast I'm going!
This means that an electron's position in an atom is described by the probability of where you can find it, and this probability is known as electron density.
Electron density!
3. The Pauli exclusion principle states that no two electrons in the same atom can have the same 4 quantum numbers. The first 3 quantum numbers describe the relative location of an electron in the atom, and the last one describes a quantum mechanical property called spin, not related to actual spin. So, the spin of an electron has an effect on the location of the electron, and thus it causes interaction between different electrons. 4. The Schrödinger equation can be applied to any atom or molecule, and its solution will tell you all the properties of that atom or molecule. The Schrödinger equation is really hard to solve because its solutions depend on the interactions between electrons in an atom or molecule. And think of those interactions as high school relationships.
I love Anthony. I love Stephanie. I love Mark.
I'm the only one in the school who's not a cross-dresser.
Complicated, and everything you do affects someone else in many ways. Similarly, besides the repulsion of the 2 electrons, there's also the exchange interaction.
It's the interaction between electrons with the same spin.
And the correlation interaction.
It's the interaction between electrons with different spins. Now for my ha-ha moment. I'm gonna spin on this bike like electron spin.
Son, are you sure that's safe?
Don't worry about it.
Density functional theory is a method of approximating the solutions to the Schrödinger wave equation. So, what it does is calculate the Coulomb repulsion, that is the effects of the electron's charge, and then estimate all the other things. Hence the name, density, from electron density, functional theory.
A functional is a function of another function. For example, the Coulomb effect is a function of electron density, which in itself is a function space and time.
This reduces the calculation costs drastically. Problems that would have taken weeks now only take mere seconds. Thus, DFT is one of the most widely used methods of calculation in quantum physics and quantum chemistry. However, there are still some problems, especially for the transition metal compounds, which have very strong exchange and correlation interactions, and thus DFT is a poor method to approximate the solution to the Schrödinger equation for them. Somebody's gonna solve these problems. Could it be you?